Hi, so today we'll be looking at this problem where it asks us to find our equivalent between terminals A and B. So first of all, we need the equations to combine resistors. So for series, our equivalent is all of the resistors added together. So however many that may be, you just add the resistances and then you'll get our equivalent for that. And then so for parallel, our equivalent is going to be 1 over resistor 1 plus 1 over resistor 2 plus, and you keep on going with that, and then you take the inverse of that. So first of all, for this problem, we should identify what nodes there are. So I'm going to mark this node 1, this is node 2, and this is node 3, and then node 4. So because the terminals that we're looking for, A and B, are on the left side, I'm going to start on the right side and slowly work my way over. So first of all, we can notice that this resistor here of 12 ohms and the one of 60 ohms, those both share node 4 and 3. So since both are attached to both nodes, we know that they're in parallel. So we can start, and then I'm just going to call that our equivalent 1 for the combination of those two. And then so that will be 1 over 12 plus 1 over 60 inverse. And then that will be 10 ohms. And then for clarity, we'll just redraw this circuit. So next we have this 5 ohms, 25 ohms, 15 ohms, and then we still have the same nodes, so we're going to go up. This will be 30, and then there will be 2 here, 20 and 10, and then we'll have 10 down here. So then I'll redraw where the nodes are. So this is node 1. Sorry, this is node 2, this whole area. And then node 3 is still over here. And then node 4. So you can see here now the 10 ohm resistor is between nodes 3 and 4, as it was before over here. So next we're going to look at the circuit again and see what can be combined next. Immediately I see this 20 and 10 ohm resistors, which are in series. So for this, I'll call that our equivalent 2. And so I'll do 20 plus 10, and then we get 30 ohms. So then again, I'm going to redraw the circuit. So this is all the same. And then you have the 30, the 10, and then the other 30 up here. We can redraw the nodes. So this will be node 1, node 2, and then because 20 and 10 were joined by this node 4, that node 4 doesn't exist anymore. So then we just have node 3 over here. And so what I notice next is that these two resistors, both of the 30 resistors, are sharing nodes 2 and 3. So those are in parallel. So what we can do is our equivalent, and I'll call it 3, equals 1 over 30 plus 1 over 30 inverse. And so what we get is our equivalent 3 equals 15 ohms. So taking this circuit that we just combined, we're going to redraw it again. So we have 5 ohms, 25, 15, and we just combine the 30 ohm resistors, so it will just become 115. And then again, labeling our nodes, we have node 1, node 2, and node 3. And so what we notice now is that the 15 and 10 ohms all share node 3 only. So that means those are in series. So we'll call this our equivalent 4. And then we will add them because they are in series. And then, so drawing it again. And so what we see now is that the 25 ohms share node 1 and node 2, which basically both of these nodes technically extend this entire wire. So we'll call that our equivalent 5. And so that'll be 1 over 25 plus over 25, and then take the inverse. So this will equal 12.5 ohms. So then redrawing it again, we have this circuit. We still have node 1, node 2, and all of these resistors are in series. So now we can just add them all, and this will be the final R equivalent. And we have 5 plus 12.5 plus 15. So then we end up with our equivalent equals 32.5 ohms. And it is between terminals A and B. Here's our answer, and I hope this helped.